Okay, so welcome everybody again, and it's time to start. Welcome to the webinar Turbomachinery CFD in the Cloud with the subtitle which is we really seriously mean an easy guide to access and use OpenFOAM for turbomachinery on demand. So this is a special professional version of OpenFOAM which the team at CFD Support has developed over the past 3 years. And so let me just start. Okay, so I need to get the cursor here over there. So now here we are. So very quickly who we are. It's about CFD Support with Lubos on the other line, then the EGI Cloud, and then UberCloud. Very quickly, it's about cloud computing on the system side. So we will briefly talk about the challenges and the benefits, and then we will get into a case study quickly, which has been performed by the CFD Support's team about Radial fan CFD simulation in the Microsoft Azure cloud. And then the highlight of this webinar is the real-life interactive demo from Lubos at CFD Support about actual fan in the EGI Cloud. So you already see we use different clouds. It doesn't matter because, as you will see soon, the TCFD or Turbomachinery CFD code has been containerized, put into a software container, closed, compressed, encrypted, etc., and then easily can be moved from one cloud to the other, and even on your workstation or on the server. And finally, we will present a nice little easy to use offer for a trial for you, which we get into very soon. So this is now about CFD Support. Lubos, may I hand over to you quickly?
Yes, please. It would be a pleasure for me to say a little bit about it. Okay, so I will just quickly mention. So CFD Support is a private engineering company from Czech Republic. We deal mainly with computational fluid dynamics, and typically we are used to deliver complete CFD engineering projects, as well as OpenFOAM support, research and development, OpenFOAM training, and of course our flagship product is Turbomachinery CFD. So I will say just a little bit about it. So Turbomachinery CFD is a unique software based on OpenFOAM. It was designed for CFD simulations of all standard rotating machinery such as pumps, fans, compressors, turbines, water turbines, both radial and axial machines, both compressible or incompressible fluid flows. The Turbomachinery CFD is complete. It's complete CFD workflow that covers all the engineering steps from the pre-processing over the simulation run to the very detailed post-processing of the results, and it's independent on any other software, so it's very comprehensive. May I ask you, Wolfgang, to move to the next line? Yeah, thanks. So yeah, I will quickly give what's its unique value proposal. So here at CFD Support, we believe Turbomachinery CFD is unique, at least for these reasons. So number one is Turbomachinery CFD has no licensing policy, which means our clients can keep Turbomachinery CFD forever, and they can use it for unlimited number of users, jobs, or cores, and that gives their investment in Turbomachinery CFD a permanent value. Number two is Turbomachinery CFD is fully automated, which means all the workflow from the initial data to the final engineering results, it can be run by a single command or a single click. And all the process is being done automatically, and for this reason Turbomachinery CFD is extremely effective. Number three is we deliver extraordinary technical support. We are proud of this service because we keep custom approach to every customer. We really deal with every issue that comes, and we are very flexible in it. So we never leave behind any issue from any of our clients, and we are very prompt in it. And also our support, we support our clients even in matters out of turbomachinery like numerical mathematics, physics, CFD, IT, or even software engineering. Number 4 would be the real tutorials are included. So Turbomachinery CFD user has no doubts about the best practice settings. There are real machines that are already preset. So you can basically take one of those tutorials, you can replace the geometry with your own, and you can modify the physical settings and run the simulation. So it's ready to use. And the last one, but not least, is the cloud computing is enabled. So Turbomachinery CFD is nowadays fully available for cloud computing. So together with UberCloud, we have a special service. There will be any information about it in this webinar. You can without any your own resources, you can start almost immediately using Turbomachinery CFD in the cloud, and yeah, it has been already taken care of all the details. So I think this is it from me.
Not yet.
Oh no, there's some more details. Okay, some more details.
One last slide.
Okay, I'll go quickly through it. So
yeah,
so Turbomachinery CFD is available both for Linux and Windows operation system. There's a graphical interface, a special graphical interface. So 100% of all workflow is in graphical interface. Those are special plugins for ParaView, so you can do everything from ParaView. And of course, you can take the decision. You can work from terminal. We leave this decision always up our clients. Turbomachinery CFD is scriptable, so you can put your scripts, your codes, and it works together with Turbomachinery CFD. There is a trial version available for 1 month, so you can test Turbomachinery CFD. You can test its performance. You can test its accuracy, and after that, you can take any action about it. We have special HTML reporting system. There are special reports. Every single simulation has its HTML web responsive report, which can be viewed on any portable device. For visual post-processing, we have special set of plugins for ParaView. Those are called TurboBlade Post system. You can visualize blade-to-blade view, meridional averages, and many more. For automating of the workflow, we use CFD processor, which is a special C++ project which does everything automatically. Yeah, and perhaps the last and very important information is all the resources are available online, so you can go to our website and you can get all the information from there, and even you can contact us and we will put all the details. So I believe these are this was my contribution for this introduction.
Yeah, thank you very much, Lubos. And I think when you start your live demo, you will quickly also access the website which you just mentioned.
Okay, I will.
Yeah, I think I remember that. So, okay. So the next partner here in this 3-partner team is the EGI Cloud. EGI was originally formed by a large European project for connecting all kinds of resources, and you can see them here. I think coming in. So. Okay, here we are. And these originally called grid computing resources, dozens of data centers all over Europe and beyond. They are recently turned into a cloud, what they call federated cloud, consisting of many clouds, exactly 23 cloud providers with altogether 300 data centers. And currently, we are using, as you see here, the Chestnut Computer Center, which is one of the partners of the EGI Cloud, where Lubos in a few minutes will run his online interactive real-time demo. Okay, so quickly, partner number 3 is UberCloud, and after having done over 190 engineering cloud experiments and case studies, we have also developed an UberCloud online marketplace, which we call Engineering Shopping Mall, with a CFD store, and I will quickly show that in a minute. So the other thing is then basically behind the scene, there are these CAE containers. These are basically software containers which we can package with any kind of software, application software. These containers are easily portable and easy to access and use, and they scale as soon as your software is scaling over many cores. The same is true then for your hardware. It's sitting on one node with 32 cores or on 8 nodes with say 128 cores and more as you like. And as you see, so there are many software containers available these days, and here you see among others CFD software. The 2 containers which are for TCFD, which is Turbomachinery CFD, and for OpenFOAM Inbox, which is another software supported by CFD support. And these containers are running on many different clouds. As an example here, EGI, as I already mentioned, Advania in Iceland, Amazon AWS on 24 different data centers around the world, Microsoft Azure, 32 data centers around the world, Bill Atos Extreme Factory, mainly in France and neighboring countries, CPU 24/7 in Germany, OpenCloud in the US, and as I said, many more. This really depends on your requirements and on the requirements of your application, of your software, of your data. Also political requirements, staying in the same country also, so that's all your decision which cloud resource then might be the best suited ones. Okay, so now the engineer in a sudden has 3 major computing tools. Number 1, usually the workstation on your desk, then a server around the corner. So statistics are that from all the 20 million plus engineers who do simulations and who have workstations, about 5% have access to larger high-performance computing servers on-site, on-premise, in your own data center. And for now, a little bit more than 1% of the engineers are already do their or part of their simulations in the cloud. And this is rapidly growing, as we see these days, for example, with engineers who register at our UberCloud website to be part of the cloud CAE community, get regular information, have access to trainings, have access to some good articles and reports, so that you stay informed about this relatively young new trend of cloud computing. Okay, so the next 2 slides are about the benefits and the challenges of using clouds. So, I mean, a major benefit of cloud, obviously, is that you have much more computing resources available than what you have in-house. So you can access almost infinite number of nodes, cores, CPUs, and so on, and especially also memory, right? So it is on-demand, pay-per-use for 1 hour, 1 day, 1 week, 1 month, depending on your project size, on your job sizes, and it can be pay-per-use or subscription or annual. So whatever you choose, it is really up to you and up to your demand. And the resources can scale dynamically, so you can go from few cores to many cores and back depending on your needs. And the nice thing is that you have the choice. You can select multiple cloud providers depending on your requirements. For example, also for hardware, for the architecture, tightly coupled, loosely coupled, algorithms, solvers, for example, everything you find these days in the so-called high-performance computing clouds. So these are clouds which are especially set up and tuned for heavy simulation jobs. And then we summarize all this usually with the buzzwords better, faster, cheaper, when you do it right. But we definitely can help you, can support you how to do it better, faster, cheaper. Okay, so there are certainly, with everything which is new, there are also additional challenges. Number one is it's new. Oops, there's a new thing coming around the corner, and I'm already so busy with my existing traditional stuff that I don't have a lot of time to look into it and to try it. And the beauty with this new technology, the containers, is the containers provide you an interactive infrastructure which is identical to what you already have on your desk with your workstation. So you don't have to learn anything new. It is really, you don't recognize that you are in a sudden running in the cloud. So, and Lubos will demonstrate this beautifully in a few minutes. Okay, security was for a long time a big concern because of your intellectual property, your blueprints, your your data. However, these days, I mean, obviously the cloud providers are very aware of this security concern of their clients, and because this is their product, right? And I mean, every cloud provider that we know has hired teams of security experts which are not easily available to small and medium enterprises, for example. So their data centers, the cloud data centers, in the meantime, are at least as secure as any other data center, be it on-premise, be it somewhere on the internet. So, which is really good news. Then the traditional software licensing, which was annual perpetual all the time, is changing these days. Companies like CFD Support, Ansys, Celia Rapco, and many others, they have turned to more short-term, on-demand licensing. As I said, one day, a few hours, 1 week, or whatever. And there are different licensing models, especially fine-tuned for the cloud, like also bring your own license. So some ISVs, independent software vendors, they allow you to use the software which the application software, CFD, for example, which you use on-site on your own in-house computer, then that you can use this license also for the cloud. And the software containers, each of the software containers, they have their own license server. And this license server is able to automatically connect to your license server or to the ISV's license server to borrow the license which you have available already. And some ISVs, they easily give it away for basically so that you can use your license on both sides, in-house and in the cloud. Others are asking for some additional fee, for like tokens, which you then, or credits, some others call it credits, which then you buy on their website, and then you are able to run your application with this specific application software in the cloud. So data transfer was a great barrier, a great roadblock a few years ago, because engineers tend to generate gigabytes of resulting data, and the question was, how to get the results back to your desktop. And there are different ways to do that, and if we have time afterwards, we can briefly talk about this as well. But this issue seems to be solved as well just recently. So previous you needed cloud expertise, to set up your simulation environment in a specific cloud. This is no longer necessary because the software containers, they are doing it all for you. So you within your fingertips, within a second, you are whoosh in the cloud, and in your container, together with your application, you upload your data and then you run. Lubos will demonstrate this nicely in a few minutes. So losing control, yes, I mean, in the past we called it server hugging. This is a really funny expression, but it demonstrates that an engineer, is a master of her workstation. So basically, it's kind of a hugging relationship. You know everything which happens in your workstation, with your data, with your application, with your resources, with the cores, which ones are utilized, which ones not, the parallel features you can watch, you can monitor, etc. So recently we have extended these software containers and included a monitor which shows you the status of your jobs, the status of the cores, the memory and everything, so that you get your full control back, which is very nice. And finally, in the past, first access to cloud is often cumbersome. However, with the CAE software containers, it is within a second. You get it to the browser, you enter your your URL, your link, and your password, and you will see this again in a minute. So I talked a lot about already. I mentioned the software containers here, and they can be applied to every application area, as you can see here. So let me move forward. So over the last 3 to 4 years, we were able to solve all these cloud challenges which you see here in that table: security, portability, compliance, etc., etc. So, and I mentioned most of them already. There is a little nice paper on our website, UberCloud.com, workstations, server cloud, comparing apples to apples. You will get, after this webinar, you will get these slides, and then you will find this link again easily, so that you can, if you are really interested in how these different cloud challenges have been resolved, then it's all in this nice little article. So the case study, one of these 190 which we have done in the past 4 years. So you see, this is team 183, Radial fancy CFD simulation in the Azure cloud. So Azure cloud is from Microsoft, the one of the largest ones around the world, and it has been performed by Lubos team, and also the software has been provided by them, the Turbomachinery CFD, or in short TCFD, resource provider Microsoft, and technology experts on our side have supported and mentored this team to make it absolutely easy. Just a quick number, so when we did our first 50 cloud experiments in the early 2012-2013 timeframe, about half of them failed for the good reasons which I've just shown, the roadblocks, and the other experiments, they took on average 3 months to from A to Z to do everything until you get back the results. The last 50 ones, which we have done recently in 2016, and you can download the compendium of 19 selected case studies from our website, and you also can send me an email and we will send them to you then. So from the last 50 ones, none of them failed anymore, and the average duration was 3 days. So this is a real amazing improvement over the last 3 to 4 years. Okay, so let me run quickly through that. I don't go into detail here because Lubos will have a similar example with his demo. So You see there is a Turbomachinery CFD, specific fan, compressible, the physical model versus the one with the computational mesh. Very often you do some types of benchmarks, which have been done here as well. In this experiment, you see on the Azure cloud, we increased the number of cores from 2 to 4, 8, 16, 32. And on the right-hand side, you see an almost linear increase of the performance, which means reduction of the runtime of this specific application. Okay, conclusion is very clear. I mean, performing advanced and demanding CAE simulation is really easy when it comes to a combination here, a bundling of the application software like TCFD plus the UberCloud containers sitting then together on Microsoft Azure cloud resources. And there is only minimal effort to set this up for you. And some of these containers are already sitting on cloud resources ready to go. So it takes you a tenth of a second to access that one. And then, it turns out, as I said, the last 50, so say the last 20 or so, have been reduced from weeks and days down to 1 day and a few hours, which is all about time to market, time to result, reducing that one dramatically. So we are very close to the live interactive demo from Lubos. What you will see is when you go to the UberCloud marketplace, as I said, the engineering shopping mall, there is a software area, and in the software area there are about 20 different software provider stores, and one of them is the store from CFD support. So when you click on that store, and then you enter the store, and you see these products here on the shelf, so to speak, waiting for you. And if you look at the second line of products, you see Turbomachinery CFD with technical support, 8 cores, next is 24 cores, next is for 1 day, and the other one is 24 cores for 5 days. In the prices which you see there, everything is included. So not only the software, the larger part is obviously the hardware. Yes, in the cloud, I mean, you have to pay for the hardware. Someone has to buy it for you and to host it for you and to do all the support and maintenance for you. So this is all included. That's what we call total cost of ownership. But you don't own the resources. You don't have to buy them. You don't have to go through this very cumbersome acquisition of resources, go to your bosses and on your knees and ask badly for additional resources. But here you go, you pay via credit card, for example, or ask for an invoice, and then you are ready to go. Okay, so let's see. After you have done that, you get a nice welcome email which says, Dear XYZ, your compute environment is ready, and you see the login information. You click on that link, you copy paste the password, and here you are sitting right in front of your container already, through the browser. This container is already sitting on the cloud, waiting for your password and waiting to be ready to start. So now I turn it over to Lubos, who will demonstrate an actual fan example in the EGI Cloud. Are you taking over?
Yes, please. So I will do it myself. So sure. Thank you, Wolfgang. So I try to share my screen. So I believe you can see what I can see now.
Yes, it's perfect.
Which is my okay, the website of the Turbomachinery CFD. So thank you, Wolfgang. I will continue with a brief example. It's very brief and simple because the workflow is simple. To get in the cloud is simple. So I will show you. So I will show you a brief example of the Turbomachinery CFD simulation in the cloud. The beauty of this cloud simulation is you always work from a web browser, no matter which operation system you have or what computer you are sitting at. You do not need any of your own resources. You only need the web browser and the internet connection. By the way, I'm sitting right now. I'm sitting at my old laptop I use for business calls, and still I'm able to do a quite complex CFD simulation of axial fan, and that's what I'm going to show you right now. So, okay, so very at the beginning, you have you start when you want to start using the cloud service, you get a link, which is a website, and a password you put in. So I have my link, which is egi.ubercloud.net, and I also have the password. Okay, there is something from the last time, so I will close it. I will start from the scratch completely. So what I believe you can see, what I can see, which is the desktop. It looks very the same way as it looks on my personal computer. So I'm in my web browser right now. I'm in Mozilla Firefox, and I have been connected to the cloud, to the EGI Cloud. And here I can do whatever I want to do, and the workflow is exactly the same as it is on my personal computer. That's the main point, right? So now I'm connected, and I can start working my usual way. Yeah, and which brings me to the end, because from now it's nothing to show, because the rest is the same, right? Okay, I was joking, of course. I'm going to show you how to simulate a simple simulation of axial fan. So yeah, so maybe what I was supposed to show you first, the detailed information about this simulation can be seen on our website, which is cfdsupport.com, Turbomachinery CFD HTML, where you can, on this website, you can click on axial fan, and here in this website you can see all the detailed information about the case I'm going to simulate right now. So we are speaking here about the axial fan. The geometry was designed in software CF Turbo, which is German software, really great software where you can design all the turbomachinery machines. All of them very smooth, very quick, very efficient. From it you can export to Turbomachinery CFD, which is the simulation tool we are speaking here about. And so in this web page you can see all the details, what are the physical settings, what are the dimensions, what are the main features and the points of this test case. So I'll go back to my window with the workspace in the cloud, and I will start working. So I'm in the cloud container right now in my web browser. I'm old school guy, so I will open the terminal, and from terminal I will open ParaView, and I will work from ParaView, because 100% of workflow of Turbomachinery CFD is done in ParaView, because Turbomachinery CFD is installed already. It was compiled a special way, so ParaView can view special plugins of Turbomachinery CFD. So I start using Turbomachinery CFD inside ParaView. So I will open the configuration file of the case, which is axial fan, and click apply, and it gives me, I can close this extra window, and it gives me the surface geometry of the case. So you can see it's very simple, it's periodic, so I will compute only periodic segment of the axial fan. There will be one rotor blade and one stator blade. I can do the basic settings, or I can check the basic settings. It's in the panel settings. On your left hand side you can see there's all the standard settings of CFD solver, and the simulation. So there's number of components, boundary conditions, physical settings, media settings, turbulence model settings, and of course the mesh settings. the test case is already preset, so I know I'm satisfied for now with the case settings. So I will switch on the next filter, which is called TCFD Manager, which is a special filter which allow me to run Turbomachinery CFD cases. So I will only call my new case, which will be written down, so I can call it my axial test case, for example, and click apply. And what I can do first is I write the case down. So there right now is being written down a new folder which is called my axial test case in the hard drive, and it's in the cloud, of course, and it's my case for now. I can edit it anytime. It's fully compatible with standard OpenFOAM. There are some special extensions which are in fact called Turbomachinery CFD, and right now I can do either everything, all the steps one by one. I can create the mesh, I can run the calculation, I can watch the results, or I can do everything in one by clicking automatic run, clicking the button run all. So I click the button run all, and this simulation is set to be very quick. It will be very fast. It will be computed in about 1 or 2 minutes. It's very fast. So now the meshing process is running. The rotor blade was meshed. Now the stator mesh is being done. Now the complete mesh is being done, and now the simulation is starting, and it already tells me that we are simulating one speed line and three computational three characteristic points of this speed line, and the simulation is very, very fast. We are simulating on 4 cores, and yes, all of them are running on 100%, and the simulation is going to be finished in 40 seconds. So I believe we can wait for these 40 seconds. Anytime during the simulation I can click, for example, update report, and anytime during the simulation I can watch the results already, because typical simulation may take minutes or even hours. So you can watch the results anytime. Yeah. What's important, any simulation in Turbomachinery CFD has its simulation report, which can be updated anytime. You can watch the results anytime, and you can for example change the settings during the simulation run and act accordingly. Yeah. So the simulation is done already. So I will start. I will take a look. I will take a look at the results. I will update the report once more because I have changed the resolution of the report, so to have it very nice. So this is the report of the integral quantities. So you can see it's really my axial test case, which is the name of my new case. The report was created on Tuesday, January the 10th. Yeah, it's right now, so I can watch the results. Here are some simulation statistics, the name of the case, number of points we have simulated, number of speed lines, rotation speed, number of components, mesh size, Y plus statistics, wall clock time. So the complete simulation of 3 points took 1 minute and 16 seconds. So it was very quick on 4 cores. There was the air in the compressor, and the fluid flow was incompressible. The fluid flow model was incompressible. And yeah, there are flow rates, residuals. I see, because I'm experienced CFD user, I can see the results are pretty well. So there is a fun characteristic, which is the FIPC characteristic. The engineers who work with funds know very well what it means. There is the efficiency. Also, everything is as expected. So yeah, so this was my simulation, and now I'm watching my report of total integral values like torques and total pressures and losses and the velocity angles and meridional angles, circumferential angles. Okay, so these were integral results. What I can also do is to watch the visual results. So I will open my Excel test case, which is this one. I will open it. I will jump to the latest time. I also switch off the original surface geometry. I can switch. Well, it's yeah. Yes, I can. Well, yeah, it's here. So I need to bring it to the front. I also need to rescale the colors to the visual spectra. Okay, maybe I can maximize it. So this is my visual results. I can do very special post processing in the TurboBlade post. I believe it's not a matter of today's example. I can only do some small post processing like filtering. So for example, I will do a slice. Yeah. So I will click on the slicing filter. I need Y perpendicular plane. Okay. So for example, these are my visual results of the rotor blade and stator blade. These are my integral results. So yeah, the simulation is done. It's very simple. I repeat, my main point is the workflow on the cloud is exactly the same as on my personal computer. I only work from a web browser. Wolfgang, may I ask you, would you like me to show something more or anything more, or is this enough for the example in the cloud?
So, I mean, I'm always very impressed because this is interactive, and you basically showed the whole workflow. I mean, you know, how your work then flows from your desktop to the cloud into the container, you know, having all your data there, the geometry, the physics, and so on, and the application, and then getting the results back. And when you move your, you know, your mouse, then to rotate your picture, etc. This seems to be almost in real time. And
Yeah.
And I already see one question which is about the size. Can you so this gentleman is asking for, so what's the number of cells which you have used in your geometry here?
Yeah, it's very few. I will show you the statistics. Yeah. So the rotor part had only 13,000 cells, and the stator part had like 12,000 cells, and altogether it has about 25,000 cells. So the model is very small. It's very tiny. But what is funny, by the experience, the small models has many times, or they have many times as good results as big models.
Yeah, this is amazing.
Of many million models, because, and that's special CFD behavior. If you, for example, if you compute on very fine mesh, the efficiency increases, and if you add another boundary layer, the efficiency is decreasing. And these effects come together on very big, nice meshes. But if you compute on rough meshes, these these phenomena fights each other, and with very small and very fast simulation, you may have in some cases, in many cases, in fact, you may have the best results and even better results than with very big models on, I don't know, 20 million cells. That's a paradox of CFD.
Yeah, but again, I mean, if you want to simulate, a full rotor in time-dependent 3D, including turbulence models, then certainly you need to have finer meshes, and these run, much longer time than which we have seen can be reduced, from hours to minutes, for example.
Of course, yeah.
So excellent. There is a follow-up question on that, which I will get back to this later. But can you hand over to me the moderation role again?
Of course I will. So I will make you a presenter right now. Okay, here you go.
Which you did, yeah. So
I did it, yeah.
Yes, I saw it. Thank you so much. So that was my last slide, which I showed right before you did your demo. So let me continue. This is the last slide already, and then we come to some of the questions. So what is now your turn, so to speak? So the next step could easily be a trial, which is you can run your own TCFD application. So with the TCFD code, which is sitting in the container waiting for you on a cloud, I think that we do the trials we do on Advania in Iceland. This is an Hewlett-Packard supercomputer, which is there, especially hosted for cloud services. And so for a trial, you can use 24 cores for 24 hours, for example. You have seen it in the CFD support store already, which we showed previously. It has latest Intel hardware, and included in that little package is support from CFD support on the CFD side and support from UberCloud for all the cloud matters. And the nice thing is that for this special offer, you get a full support on the CFD side, on the hardware side, on the container side. So we basically take you step by step to the cloud, help you to set it up, to set your application up, because the software is already there. As we said, you have to upload your data file, and then you can start and run several applications, test it, you can do benchmarks, whatever you can achieve in 24 hours then. With that, I would like to thank you, and also thank Lubos for his great interactive demo. Very impressive, Lubos, as always. So I can start. Let me check the time. We still have 10 minutes, which is nice. So at least we can have a few questions then going through. I have the question here. Okay, so there is one that's interesting. Dennis is asking, are there any EGI cloud sites in the US? And yes, there are, but I have to ask, I don't know them. So there is, our contact in EGI, Sai Holzinger, can certainly answer this question. Dennis, I sent you an email with this information in 1 or 2 days, depending on when, etc. So then someone is asking, are there really 20 million engineers who do simulation? Yes, so I have to say this number is based on research from John Petty, which many of us know. This is the workstation guru, and currently there are about 1.5 million workstations sold every quarter, This is 5 to 6 million, and with a lifetime of 3 to 4 years, you get close to the 20 million. And we are all aware that this is a very rough estimate because these are engineers and scientists, okay? Because also scientists, you know, in the academia, in research centers, etc., they are all doing these kind small to huge simulations, and they are all interested in bursting into the cloud for bigger geometries, finer meshes, more physics, etc., right? So that was that one. Sorry, Lubos, that was more on my side.
No, it's okay.
Fabrizio has another question. This is for you. Why to use incompressible fluid?
Yes, I will answer it.
That's a good one, yeah.
Yeah. So it's the air. The media is the air, but still it's used as the model is used incompressible, which is typical in these kind of simulations. The CFD engineers usually have typical criteria. Unless the Mach number is lower than 0.3, you can use the incompressible model. Right. So I will repeat it. Unless the Mach number is lower than 0.3, you can use you are on the safe side. You can use the incompressible model, and also in some other kind of flows, for example, on compression, pure compression, the other criteria is unless the density changes less than 15%. So, for example, there's a Mach number for high-speed flows, but you can imagine there might be a piston compressing the air in the room or in the chamber, for example. There is no such a speed. There is low Mach number, but the density can change, right? And if the density changes lower than 15%, you can still use the incompressible fluid flow model. So in all the other cases, you use compressible fluid flow model. Yeah. So that's the answer. Yeah.
Yeah.
And we have. Yep. Yeah, I'm sorry, we have a very low Mach number here, about 0.1. So
exactly. So
okay.
I think that was a good answer. So that's, and Fabrizio also asks, what about fatigue problems?
Yeah, that's another branch we don't deal with. So we are dealing with CFD, computational fluid dynamics, and we don't use these fatigue, and it's another story. Yeah, so it's off topic for us.
Yeah. So a quick answer, Fabrizio, is that we have containerized finite element codes as well. You know, among others, for example, Abacus, everybody knows that one. So if you want to know more about this, just shoot me an email, and we can give you more details about that one. Then there's not really a question. Gregor said thank you. Okay, you're very welcome. Then the cases can be downloaded as full OpenFOAM files, Lubos. So like
I'm sorry, I missed. The
cases are then downloadable as full.
Yeah, very simple. Sure. I can show you. I'm sorry, I will take back the presentation.
Okay.
So
sure.
I believe you can see my screen now, and I will go back to the command line.
Website, right?
Okay. Oh no. To the command line in the computer. So I'm still in the cloud, and I will. Yeah, not this. I will open the file manager. I personally prefer a Midnight Commander, and I will move to my run directory, and where I have this axial fan tutorial. And yes, the case we have run right now is called my axial test case. So I will open it, and people who ever used OpenFOAM can immediately see that it's the it's the typical OpenFOAM case where you can see there's a 0, some results in the directories. By the way, those are those 3 points we have simulated: constant and system. And of course, Turbomachinery CFD is very advanced software for Turbomachinery. So it creates many other directories where it stores the data which you can analyze which you can further analyze. So yes, the answer is yes. You have very the same space on your hard drive. You can store the data there, and then you can download it easily any typical way. You can share the data via, for example, some service online. Yeah, very typical via Dropbox or something.
Okay.
So no big deal, and all the data. Yes, you have.
Yeah, we have more questions. Thank you so much, Lubos. So there is a question about cloud licensing for any kind of ISV software, so like yours. But as we already mentioned, there are different models, and Aniko is asking especially for one ISV. So this one ISV has elastic licensing, and so in fact, yes, you can use your existing license. You want to talk to your software rep, you know, where you got this license from. It is almost brand new, but yes, you can do. Every ISV has a little bit a different licensing model for the cloud. So ideally, I mean, either you ask us, I think we know all these differences and the different ISVs, or you ask your software provider directly. So scrolling down, there is another one from where I have an application that involves thermal transfer to rotating water-cooled roller. Could this be modeled? It has no turbo exactly. It has not turbo exactly. I don't know. Did you understand, Lubos?
Actually, I'm a little bit back because I did something. Okay, I'll read it. I have an application that involves thermal transfer to rotating water-cooled roller. Could this be modeled?
Yes or no?
I think this is very special. So the asker is Gerard O'Boyle. I will ask you, Gerard. Send me an email, and I will deal with this seriously afterwards, after the seminar, because it's very. I would need, for sure, I would need some more details about this.
Great. So one last question. Okay, the case for the webinar participants offer must be about fan turbomachinery studies only. That's a good question. So okay, so this offer certainly was meant to be for this specific TCFD application, but if you want, for example, to try a general OpenFOAM application with CFD supports OpenFOAM in box, we also have that containerized. We already have a few trials running because we had a webinar about this in late November, I think, so we still have a few dozens of trials there up and running, which will end in February. But you can join. So if you think you have a nice OpenFOAM which is not really connected to Turbomachinery, still send me an email, and we definitely want to help you. So, Lubos, it is 5 p.m. Central European time. I would like to thank you. Thank you so much for your great presentation.
Thank you very much. Yeah, it was a pleasure. Nice.
Okay, and we want to thank also the audience, the participants who have hopefully learned a lot and are encouraged now to try themselves. Okay, so thank you very much. I wish you all the best and hope to see you soon somewhere else. Goodbye.
Okay, goodbye. Let's stay in touch. Bye-bye.